Hi everyone again. We have an AI track now with 6 great presentations. We have 1 hour, and at the same time we're starting CTFA, CTFI that you can play during the first and second day. Individual participation, great quests, so definitely do try yourself. And during today, we will have a 1 hour break from 2 to 3 o'clock, and then we will continue with the presentations. And I'd like to invite Fyodor Yemelyanov with his presentation on the multi-party computations. Hi everyone, my name is Peter and I work at BloomTech, and I work on multi-party computation for quite a while, so I will talk to you about it. The clicker doesn't work, unfortunately. Okay, it worked. Do I change the slides or you change the slides? It was turned on. Okay, so yeah, we will figure it out on the run. So let's start with a simple motivating example, and the graph here shows the computer vision system's progress in the quality. And as you can see, in the beginning, it's quite slow in development, but in 2010, we have a jump, a quantum leap, and even exceeding the level of 94.9. Do you know what it is? Yes, that's a human level of image recognition. So in 2015, the robots started to distinguish cats on the photos from dogs on the photos better than the humans do. So let's go back to 2010 and ask what has happened there. ImageNet was published in 2010. The dataset that had thousands of images that were marked, and then the crowd started to work on this. So high-quality data is sometimes a revolution or a game changer, but it's always good. So here's another example. In 2006, Netflix, well-known company, decides to exploit the crowd, and they publish the data set that has the data about the viewers, the movies, and the ratings set by the users. So those are not cats, and of course it's the personified, and the names of persons and films are changed, and some data was even tinkered with. So Netflix thought about privacy. So the teams were contesting, and $1 million was the prize. And in 2009, 2 or 3 smart guys from Texas University decided to correlate Netflix data with IMDb data and compare the marks set by the users and dates. And thus they were able to re-identify nearly half of the Netflix dataset users. Nothing terrible happened, but of course there were court cases, the contest was closed, and the story went viral. So the data, making the data safe for the data subjects, is not really a very simple task. This is a standard slide I use, and usually we choose 2 or 3 or 4 data leaks happened recently, and we put on the slide what has leaked. So this time we decided not to do so. There's a lot of leaks. Maybe someone will get hurt by not mentioning them. So I could not resist searching myself in any data with, of course, some trepidation. And sometimes friends ask what's about them there, and usually also I find nothing. And recently we had a leak where I found myself and most of my friends and colleagues, and of course I didn't like it. The case here is that user data has long-term usefulness. So if you lost the card's numbers, it's a catastrophe, right? But you can call the bank and block the card, and that's it. And the problem is solved. But if a person is, for example, seriously ill, then, it will not be fixed soon, but it can be commercialized for long term. And data leaks are not the only stopping thing, because the companies don't want to exchange data, because this means lack of loss of value for this data, both for the person who gives the data and for the one who receives. For example, I want to get a pizza, but this data cannot be sold fast. In 20 minutes, I will not be wanting a pizza. And if I'm a skier, that's a good thing, because for some time I can trade this data. And of course, exchanging data, you can also get in conflict with some regulator, and the consequences can be very different, like a very big fine or something very mild. So the companies don't want to invest in such synergies, even if it broadens the business. So what do we do? First of all, we can do nothing. We can stay in the same paradigm and base our products on that paradigm. But the risk is high that someone will outpace you for credit scoring, for example. I remember the times when you had to fill in the form, and that was the scoring. Now, a couple of databases checked. And you can still do it today, but you will be losing to those who are, more aggressive and, for example, who know that I am a skier. So the idea number 3 is that collaboration in data fusion is a useful thing, an important thing, and to some extent, it's inevitable. But you need to know how to work with it. And the answer lies in the technology zone. The landscape is like this. You have 5 technologies. I put them on 2 axes. The higher, the more protected your data is, and to the right, the more the higher precision. So starting with what Netflix did doesn't work. Then we have differential privacy, great algorithm, but doesn't work very precisely. And the idea is, let us put some noise in the data. But the story here is that you either have too much noise or too little noise. The data is either not protected enough or the value is destroyed. Then secure enclaves, hardware technologies to the right, on the button, great thing. But unfortunately, in the current Russian realities, those technologies are not actually accessible. So then we have only homomorphic encryption and multi-party computing. And as MPC is my interest, then let's step deeper into this. So secret split is a very well-known crypto algorithm in Genta, the city. There was a room that stored all the important documents from administration, like Holy Inquisition documents, and there were 3 locks on the door with 3 people, the highest standing people, owning the key. They had to gather together and then open their locks and doors. So this is secret split. And this is digitized thing. This is the true the true thing. So I got the penguin and I generated a random mask. So if I give you this mask, I disclose zero information about my penguin, because this can be part of penguin, of Mona Lisa, of night shift, and whatever else. And the idea is that there are protocols that enable you to summarize, multiply, and do other things with the numbers without knowing only their parts. So this algorithm is very simple, and to be very direct and precise, let me show it to you. So 3 people have a lot of money, and they would like to decide how much money they have together, but not knowing how much other ones have. So 3 people would split their amount of money into 3 digits. So we have 3 parties, and one number is kept with you, and then the 2 are sent to the others. So on the second step, everyone has 3 random numbers, and they cannot decode the parts, the original number. So they just summarize those numbers and go to step number 3. They have 3 random numbers. Of course, the sum of 3 random numbers are random, and you have -30 plus -3 plus 43 equals 10. They can shout together, and or they whisper to someone, for example, to me, and then I will be the only one knowing the result. And I did not see the data that the calculation was based on, and I didn't even know the algorithm. Now, the same with the multiplication. It's more complex. It's not the protocol itself. It's rather the main idea. To multiply x by y, we add a and b, where we mask the originals, we split the arguments, and we come to a conclusion where parties can multiply the masked version of numbers. I simplified this a little bit. It's a little bit harder, but you can multiply. And you probably know what this is. Linear regression, machine learning. BI is the weights, and XI are the predictors or independent variables. So this formula has nothing but multiplication and summation of numbers. So we have parties running the protocol and calculating the linear regression, not knowing the predictors, not knowing the weights of the model. So linear regression is a simple algorithm, and if we dig deeper, pretty much any machine learning method is, in the end, just pluses and multiplications. So you can manage the accuracy by adding the number of the length of the polynomial. So you can operate by digits, you can operate by data, but you can actually split them and make it a secret. So here's how it's organized on the physical levels. Our system is distributed. When a party wants to participate in our project, we give it to him as an open source, so it can be audited. And then the party runs this module in their computational module and becomes part of a mutual computational network, which is not designed not to calculate the machine learning models, but to protect data of all the parties. And of course, there's a lot of protocols to the orchestration to ensure that everything works fine. But the orchestrator does not compute. And thus you have a network where you can confidentially get the data, cryptographically mix it, and in the end you can get aggregated data that cannot be proven, that cannot be deciphered back and personalized back. So where can you use it? Let's start with what does the taxi film have to do it. It's one of our first cases that we ran 2 or 3 years ago. Those years there were several operators of a taxi fleet, and the drivers were distributed between them. And each and every operator was limiting the time and blocking the driver from driving more, because of course the driver is tired and needs to rest. But the drivers that were very willing to drive, I can drive 8 hours with Yandex, then work 8 hours with City and 8 hours with Get. After 24 hours, Yandex thinks that I slept enough and starts giving me orders again. So this does not look like a good thing. But exchanging information about the drivers and how long they work is not something that the aggregators want. So the task is, how do we calculate the amount of time the taxi driver worked without knowing how much they worked in any separate one? This was exactly the algorithm we described in the beginning, and of course this was very easy to do. First two had 90% of the market, and we ideally need 3 parties at least that even or better if there are more of them, and they need to be quite precise. But this is a good example of the idea that with a very simple operation you can solve a task that was unsolvable previously. Hooray! So the next point of application of those technologies is tech. Ad tech, ads and marketing, and there's a lot of tasks with cross correlating the identifiers. So at maximum you need to be like how many boys have done this or that, or how many women have done this or that, or sales lead to analyze the result of the marketing campaign results. So this is called private join-in compute, and we do such things. And recently Facebook has started to work very much, very deeply in that direction. They're now called Meta. So we have quite significant competitors here. And the thing I love the most, fintech. Why I love it the most? Because first, there's a lot of banks, and we won't have the issue with taxi aggregators, and money loves silence. The amount of tasks is very big, starting from credit scoring and also including anti-fraud activities. And the collaboration can happen between the banks, bank to bank, and also between banks with non-banks. We had a pilot with quite a big bank and quite a significant telecom operator. The task was to generate a data set. So Telecom had 196 predictors and 1 vector, and the bank had 90 predictors. The idea was to train the model so that the parties don't see the predictors or the target the target variable. So we had linear regression and multi-layered neural nets there. And here's how it looked. Okay, right. So it's important to pay your attention here to on the 600 seconds. For people who know that besides data sets were big, 5 million rows, and usually it's much faster. So the cryptography, of course, when you add the cryptography, there's a lot of overhead. So our model had to spend 600 seconds, and on the sixth epoch we had the highest number of row CAUC 0.91, 0.76. Then inference was 23 seconds, 1 million rows. We didn't know the targets for this inference, and Gini was 0.51 to 0.517. So this was an experiment, and of course they could train this model on other data. And so on other methods we had better accuracy, despite the fact that we had our model using cryptography. And we had 8 times increase because we ran it 1 year ago. And as we scaled this since then, now we would be 8 times faster running that experiment, not 600 seconds, but maybe less than 10 seconds. So that's pretty much it, and I'm happy to answer all your questions. And also the speakers can choose the person to be given a prize for the best question. And we'll give the T-shirts. Thanks, Peter. 2 questions. First, regarding the business part. Generally speaking, companies are not very much interested in selling the data. So the model is each and every company is using their own data and then use the data for inference. And this is important. This is good because apart from you don't give any data. But this model is a third-party model. Why would it be interesting to the companies? Because the economy doesn't look very well. If they can, train their models on their own data. So we look a bit differently on this. It's more convenient to train on your own data, but the synergy is very valuable and possible. When you multiply the amount of data, the result is usually better. And we are aimed at creating an environment for confidential information synergy. So I can take the same banks. I have accounts in 3 banks. One is for salary, one is for a good card, and the third one is where I store my money. But there's a tax office. No, your tax office does not have enough data. Talk to the banker you like, and he will explain to you. To the previous slide, how just is it to compare the models trained locally and with NPC, as it limits your amount of methods. With local training, no one will use the regression. Probably, people will use gradient boosting, something even more, something even better. Then my intuition says that the results will be better. And here you are limited by the method. You are right. If you use gradient boosting on the data, on the merged data, yeah, the results will be better, but the experiment cannot be run. So the Gini number is better than the number that we received with gradient boosting on the separate data sets. So you cannot join the two data sets in the real life. That would be a compliance issue. Thank you. My name is Iva Sokolova, and the questions I have first is the cases and the examples that you described. How much time did it take? And the second question is, if we grow the number of sites from 2 to 3 and more, how more difficult do the cases become? The implementation takes a lot of time. Yes, a good question. Technically, everything can be solved. There's a lot of optimizations and a lot of hints and tips and tricks. You can split the secret. There's implicit schemes, not between 10, but between, for example, any 3 of 10. Technically, everything is solved. Technologically, there are issues with implementation. So with Taxi, unfortunately, we did not launch it, but we implemented it within half a year. And with banks, it's still in the implementation phase, different issues. There's a lot of compliance questions. Legally, you need to prove that this can be done, and there's no bank secret loss. And if you implemented anything in a bank, you know this takes a lot of time. Hello, Andrew Pinchuk, and I wanted to ask about running the system. So after the proof of concept, do I get it right that each and every party should update their data for the results to be usable? This is the first question. And the second one, in case you get additional data, how easy is it to add the data to the system so that we could get extra value? On the first question, it's true. Every country, every party creates their own data set and supports it. Second question depends on the party. If the party is ready, I am ready to implement within 2 days. Dmitry Ismail, the question is, yeah, I'm here to the left. Technologically, homomorphic calculations are quite heavy. So can you comment on how hard is it to expand this schema? And the next question is the implementation cases, marketing and everything that has to do with it. Online sales. That would be quite interesting and to be put in this scheme. So what thoughts do you have for maybe what you think about developing that? So on the first question, 600 seconds is the reality that we have. Unfortunately, we cannot run it faster, so we improved it 8 times. But we had to significantly work on the complexity, and we needed to merge the segments so to get better targeting. And there's a lot of issues there. The segment is opening up, and however secretively you gathered it, there's a lot of potential leaks. So we tried to add the third party that would not know anything about the data, that knows about the segment 42, show the cat's ads, but this also creates potential information leakage. So instead, we go to private joint compute, where you need to, cross-check the identifiers and look at how the sales have changed, or work on 2 segments, deciding how many boys have bought Gillette razors. And the follow-up question regarding the GDPR. Yeah, we thought about it, and we started working on this maybe 4 years ago. The international markets were available then, and so the Commission, the GDPR Commission, 1 year ago has approved the usage of multi-party computations to anonymize data. So it is really an option. Next question. Peter, Artem Menisov, Mozhaysky Academy. For example, we have MedTech, where you have discrete data sets with low amount of data, low amount of patients, and as they cannot create a compute cluster, anonymizing and noise will not help. What should they do? And maybe we can run NPC, a broaden NPC on their side by, for example, adding some NPCs, splitting the data set. So let me answer. So let me start the answer with the first, and on the second we will have a discussion because I didn't understand it quite well. First of all, if you don't have computational power, there's no silver bullet. Well, no. I meant that we have small amount of players, and we don't have. We cannot use noise. We cannot use anonymization. And if we have one player, we cannot pass the data. So the doctors would like to save the world from AIDS, cancer, etc. But they cannot pass the data. They don't have the competencies to create the models. What do? So you'd like to gather data from the doctors? Yes. Yeah, good question. I don't know the exact answer. I understand they are all anonymized. They remove the name of the patient and then they send using WhatsApp. But with your scheme, with segment splitting and obfuscating the personal data on the left, this does not work, right? So this is a target segment for reducing the quality of data in those technologies. Well, I was specifically mentioning homeopathy and non-proven medicine. The same is about anonymization, and you can trust in the anonymization like Netflix did. And it was not a good idea. So anonymizing is not an answer. Okay, good. So can we run some MPC-like algorithm on one party? Well, yeah, the party can run two servers and split the data and then run it onto servers. Yeah. Doable. It's one of the answers to your question. I don't know the exact issue, but you can definitely do it. Okay, we won't go into a deep discussion, but thank you for the question. It's a good one. Hello, Peter Henkin. The question is less on the technology side and more on the fintech. How did you solve the 152? Did you work with the regulator? Yeah, we do work with the regulator, and of course I know that I can create a scheme with no personal data, but we start from the idea that the passport number, regardless of how much hashes you run on it, is still a personal data. So we close this question with the user agreement, and regarding the bank secrets that are regulated by the Central Bank of Russia, then we are waiting for their position on this topic. Do you have any other questions, dear audience? Thank you, Peter. Alexander Konkov, Umani. And the question is, can those systems protect themselves? So one of the parties is compromised, their data is poisoned by some false data, what can we do? We can actually do a lot. And the NPCs there are different levels of information protection. We thought in the presentation, we considered the parties to be to have no malicious intent. But you can think of models that have malicious parties, and they called verified secret split that allow, without seeing the data and working only with the secrets, to understand whether the data was poisoned. So if something went wrong, we ban the participant and decide on the results and can run an investigation. Thank you. Great question. Thank you, Peter, for your presentation. And you talked about MPC for binaries, for numbers, but what do we do with the images or the language? Well, I don't know. I didn't try it. I think it's the same as with the pictures. And you probably will have to, convert the data into some digitized form, but then you can run pretty much the same algorithm on them. One more question. You talked about the legislation, and what is your own opinion on how much is our current legislation advanced to actually allow MPC to be used? The answer is, I will give you a gift on that. Great question, and it's hard to answer it. If you have asked this question, like, say, 2 months ago, the answer would be 1. And currently, I don't know, the positions of the regulators are changing very fast, and there's a number of unpleasant centralization events. Some can do everything, some can do nothing. And let us pretend that nothing happens and live in a paradigm that we had till the end of January. And at that moment, our regulators worked quite modernly, as they were answering the challenges of the time. So now they stopped doing this, and I hope they will restart doing this moving further. Thank you. And thank you for your presentation. The question is, when we talk about the new systems, like in the beginning of 21st century, we had elliptic circles entering the math, and now we have a new idea with parallelized calculations. Did you use something to prove the crypto resilience and what it can be hacked? So the question is twofold. We have the base on this, we have the database, and it's analytical, and we can prove that what we do is secure because we use the cryptographic primitives that are known to be secure. Regarding the contests and the practical application, I don't know of any such activities, but we do plan to run it, and probably with positive technologies, hopefully. Yeah, we'll be glad to. And yeah, I think you'll create something like HackerOne where you will be able to give someone a bounty for hacking. Okay, no more questions. Peter, I hope you'll be here, right? And I hope we'll be able to find you. So with that, right now, we say thank you. And we choose 2 questions. I like the legislation choice. Black or white? This is much harder. Yeah, white. And the black one. We'll go to the person that sits over there. The first question was great. Thank you indeed, dear colleagues. Thank you.
Всем спасибо. Следующий доклад будет в 12.
Thanks a lot, and the next presentation is at 12 o'clock sharp.